Hey guys, before we go over the notes, I want to go over this practice 1.2, adding and subtracting polynomials that we did last week because I kept seeing some common mistakes. First off, don't get discouraged by your grade if you didn't do as well as you would have liked to. It is hard because first off, I'm not there, obviously. So if you have questions, it's harder because I can't just answer them right then. Also, these problems aren't just your basic problems, okay? They're going to be upper level problems, so they take a little bit more thinking and a little extra work. I do this that way whenever the STAR test comes around, that you're like, this is so easy, okay? We did harder problems in Miss Carpenter's class, okay? So I want to prepare you for that. Also, you can go back in and correct this. So after you see your grade, you can go back in and click on the Google slide and then correct it in a different color and then hit resubmit. Okay, and I'll go in and fix your grade if you would like to do that. So if some of y'all want to take out a piece of scratch paper, you can be writing this down as I do them with you. Let's start with problem number 2. Okay, so I have 3x plus 1 minus 2x minus 2. So a lot of y'all subtracted the 2x, but you forgot to subtract the minus 2. This subtraction sign, you have to distribute it out to each term because you're subtracting each one of them. So I would do minus 2x and then minus negative 2. Well, what's minus a negative? It's really a positive. So that's going to change the sign to a positive 2. Then all you have to do is combine your like terms. So you'd have 3x minus 2x, which is 1x. And then positive 1 plus positive 2, which would give you x plus 3. Okay, now let's move on to number 7. This is another one where we're subtracting something and you forgot to subtract the second term as well. So I have 2x squared plus 4x plus negative 6x squared. So because I'm just adding them on, I don't change the sign. So basically you can just get rid of those parentheses. Then I still have plus 9, and then I'm subtracting the 6x, and then I'm subtracting the 3. So be very careful. Anytime you see a negative outside of a parentheses, you have to distribute the negative or that subtraction sign to each term in the parentheses. Now we can combine our like terms. So I have 2x squared minus 6x squared, which would give me negative 4x squared. And then I have 4x minus 6x, which would be negative 2x. And then my ones, positive 9 minus 3 is positive 6. Okay, now I'm going to flip to the back of this. Okay, let's look at number 9. I think y'all saw decimals and you were like scared or something. Decimals are okay. If you don't know how to do 4.2 times 5 in your head, use your calculator. It's okay. Alright, so we need to distribute out this 4.2 and multiply it by the 5x and the negative 1. So I would type in 4.2 times 5x and get 21x. And then 4.2 times negative 1 would be negative 4.2. Most of y'all were okay on this step. Now we're going to come over here. What is in front of the 3.4? If you said a negative, you are correct. Okay, remember that you have to pay attention to those signs, okay, especially whenever you're distributing. We're multiplying the 7x times negative 3.4. So negative 3.4 times 7x is negative 23.8x. And then negative 3.4 times negative 3 is positive 10.2. So I think just that negative threw off your whole answer. Now all you have to do is just combine your like terms. So you're going to combine your x's. We've got 21x minus 23.8x, which would give you negative 2.8x. And then negative 4.2 plus 10.2, and that equals 6. Alright, so I think just going over that might help y'all with some of the other problems that you miss, especially if there's a negative that you have to distribute. Alright, go ahead and turn to your unit title page. Today's notes are 1.4 two-step equations. So we're moving on up, going from 1 step to 2 step. Okay, so we're going to do some more work with algebra tiles. If you don't actually want to get them out, that's okay. You can just use a model. If you actually want them out and you want to get them out and then draw a model, that's perfectly fine too. So let's start off with 2x's four negative ones, and then that's going to equal 6 positive ones. So our goal is to figure out what does one of these x's equal. So in order to do that, we have to get that x by itself. So we have to get these 4 negative ones gone from the left side and move them over to the right side. In order to do that, we have to add in 4 positives so that we can create these 0 pairs. So I'm adding 4 to the left side, and I need to add 4 to the right side, because remember, whatever you do to one side, you have to do to the other. So whenever I add in those 4 positives, I can cancel off my 0 pairs. Positive, negative, positive, negative. So all of my little ones on the left are gone, and that leaves us with 2x's equals 10. So I want to figure out what does 1x equal. So we're going to divide this into two groups. So I need to half this group of 10. So half of 10 would be 5, so I need 5 in one group and then 5 in another group. So this shows me that 1x has to equal 5. Alright, now let's check it. So if I plugged 5 back in to this equation, I would have 2 times 5, which is 10, and then 10 minus 4 is 6. So we did it correctly. Okay, moving on to this next example, I've got 2 times x plus 1 equals 4. So let's start with the parentheses, just because that's order of operations. I need an x and a positive 1. But I have to double that because of this 2. So I need another x and another positive 1. I know that has to equal 4. Okay, so we need to get the x's by themselves. So I need to get these little ones gone from the left side. So I need to subtract or add in a negative. So I would add in a negative 1 and then another negative 1. And whatever you do to one side, you have to do to the other. So I need to add in 2 negatives to the right side. Now cancel off your 0 pairs. So positive and a negative cancel, positive and a negative cancel. But I also have some 0 pairs on the right side. So positive plus a negative, positive plus a negative. So I can see now that I'm left with 2 x's equals 2 1's. Well, we want to figure out what 1x equals. So once again, I'm going to divide these up into 2 groups so I can get an x by itself. And I have to divide the right side up into 2 groups. So each group would have 1 unit in it. So this would tell me that 1x would have to equal 1 unit. Okay, check it. Plug it back in. If I plug in 1 for x, let's see if it equals 4. So this would become 2 times 1 plus 1 is 2, and then 2 times 2 is 4. So we did it correctly. All right, moving on to this last example of algebra tiles. I have 3 negative x's, 4 positive 1's, and it's going to equal negative 2. So I need 2 negative 1's. Okay, same thing. We want to get these x's by themselves. So my first step is to get rid of these blue 1's. So I need to add in 4 negatives. And then I need to add it also to the right side. Now cancel off your 0 pairs. Positive, negative, positive, negative. So I'd be left with 3 negative x's equals negative 6 1's. So now we have 3 x's, so I need to divide this by 3. And then I'm going to divide these 6 units into 3 groups as well. So if I divide them into 3 groups, that means each group would have to have 2 units in it. So that would tell me that 1x has to equal 2 1's. But this is a negative x. I don't want to know what negative x equals. I need to know what positive x equals. So whenever you're working with algebra tiles, in order to change the sign, you just need to flip to the other side, which is basically the same thing as like multiplying by a negative 1. So I'm going to go ahead and flip this one over to make it positive, but since I flipped everything on the left side, I need to flip everything on the right side of the equation too. So this would become x equals positive 2. Alright, so now let's check it. I'm going to plug it back in for x. If x equals positive 2, I'm going to make sure that it makes my equation true. I need to check my solution. Negative 3 times 2 is negative 6. And then negative 6 plus 4 is negative 2. So we did it correctly. Negative 2 would equal negative 2. Okay, move on to the next page. We're going to get rid of the algebra tiles. Everybody say hooray. Alright, let's go ahead and get started on this first one. So I have negative 2x plus 9 equals 5. I'm just going to rewrite this so I have a little bit more space and I write really big. Y'all are going to learn that about me. So I want to get x by itself, just like what we did with the algebra tiles. So this would mean I have 2 negative x's, positive 9 1's, and it equals positive 5 1's. So I need to get rid of this positive 9 to get the negative 2x by itself. So I need to subtract it. And whatever I do to one side, I have to do to the other. 9 minus 9 is 0, so that would leave me with negative 2x equals 5 minus 9, which is negative 4. Okay, if you've been taught to draw a line here and keep your left side separate from your right side, that's fine too. Just whatever you're more comfortable with. And now I have negative 2x equals negative 4. But I don't want to know what negative 2x equals. I want to know what 1x equals. So in order to get x by itself, I have to divide each side by negative 2. Because I know negative 2 divided by negative 2 is positive 1, which would leave me with 1x equals negative 4 divided by negative 2, which is positive 2. Now let's check our work and make sure that it makes sense. So we need to plug it back into the original equation. So I'm going to plug in a positive 2 in place of x and make sure that I get a true equation. So negative 2 times positive 2 would be negative 4. And then negative 4 plus 9 is positive 5. So we get a true equation. Okay, moving on to number 2. Y'all are going to do another iExcel today, and for some weird reason, they write problems like this, okay? They have k over 4, or k divided by 4, minus negative 4 equals 8. If you see a minus and negative sign, just go ahead and turn it into a positive. Okay, remember, minus negative is the same thing as a positive. So let's go ahead and rewrite it like this. Now I'm trying to get k by itself, so I need to subtract 4 from each side. 4 minus 4 is 0, which would leave me with k divided by 4 equals 8 minus 4, which is 4. Now I just need to multiply, because the opposite of dividing by 4 would be to multiply by 4. So I'm going to multiply each side by 4. This would leave me with 1k equals 4 times 4, which is 16. Alright, let's check it. Plug in 16 for k. Sixteen divided by 4 is 4. And 4 plus 4 equals 8. So we did it right. Okay, moving on. Dun dun dun, decimals. Gotta love them. Now our variable is h, so I'm wanting to get h by itself. So my first step would be to add on. Actually, I think I want y'all to try this one on your own. So we're going to pause the video here in just a little bit. I want you to try this one by yourself. Don't get scared because it's decimals. Figure out what h equals, and then you can play the video and see if you got it correct. So your first step should have been to add 1.75 to each side. Negative 175 plus positive 1.75 is 0, so it is gone, which would leave me with 27 equals 2.25h. Then I would divide each side by 2.25 to get h by itself. And then 27 divided by 2.25 should have been 12. So 1h equals 12. Alright, last problem. I have negative 1 equals 5 plus x divided by 6. So x, my variable, is in the numerator, and I need to get it by itself. So in order to do that, I need to get rid of this denominator. So the opposite of dividing by 6 would be to multiply by 6. So I'm going to multiply each side by 6. 6 divided by 6 is 1. So that would just leave me with negative 6, because 6 times negative 1 is negative 6. And then I would just have 5 plus x left on this right side. Now I'm going to get x alone, so I need to take this positive 5 and subtract it. Negative 6 minus 5 is negative 11. 5 minus 5 is 0, so I would just get x equals negative 11.